Good afternoon everyone. My name is Praneeth Bankar and in today's video we are going to discuss about a data structure called stack. Now in this data structure we are going to discuss about its basic how does a stack work and about its FIFO first in first out principle and even about its and further moving forward about its two basic algorithms or two basic operations called push and pop. We are going to discuss what does it mean and also it's we are going to understand the logic behind its code of push and pop functions of a stack. So let's move on. Now, moving forward with stacks, let's understand exactly how this data structure works and also about its two main operations, push and pop, and also about its code and understand it. Now, to begin with, let's imagine stack as a stack of books, for example. Like in general, we pre-assume that the data structure which is linearly placed is like array, horizontally placed is like array, and vertically placed is stacks. Like for example, let's assume this is a stack. This. It is a stack of element 1, 2, 3, 4, 5, 6, 7. 7. This is a stack of 7 elements. Now, in stack, we follow the principle of Philo. Sorry, by mistake, in video I consider this Philo as FIFO by mistake, but no, this is Philo. Philo stands for first in, last out. First in, last out, and stack follows this principle in its operations. Now, what does first in, last out exactly mean? For example, if you push here, okay, let's first clear that push in stack means insertion, basically inserting an element in stack, okay, and pop in stack exactly means deletion or deleting an element from the stack. Now, first, let us clear that push and pop in stack doesn't cannot be done on any specific index or wherever you want in between the stack or anything. Push will be done from the bottom, it will push the element above, and pop will be done from the top, it will okay, push will be done from the bottom, it will increment it as it get as the element gets pushed, the top pointer will increment to next position and so on. And in pop, always the element that was last inserted uh, will be first deleted. That's why this principle is also known as LIFO, which is last in, first out. Now, for example, let us push first. Let's assume we first pushed 2 into the stack. Now, let's assume we pushed 4 into the stack. First, let me tell you about TOS. TOS basically stands for top of the stack. Top of stack. Now, top of stack is a pointer or is a variable we use in our code for the stack to basically demonstrate the basically demonstrate how the insertion pushing operation, while we push the element, the top of the stack increment by 1 every time we push and insert or push or insert an element in the stack, and whenever we delete, the top of the stack always deletes the element and it drops down to the bottom, to its bottom stack by 1. Now, for example, and in the initially when there are no elements in the stack, for example, before we pushed this 2 and 4, the top of the stack was at -1, is set at -1, just because this demonstrates this this is considered that the stack is empty, and so TOS equal to -1 basically means that the stack is empty, and whenever we push the first element into the stack, whenever the TOS is incremented by 1 to 0, is incremented from -1 to 0, like, and the stack has the same indexing as array, like the first index will be 0, 1, 2, 3, 4, 5, 6, 7. Now the stack has same indexing as array. We start from 0th index and move on forward. Now TOS initially is -1. TOS initially is -1, and it increments by 1 whenever we insert the first element. 2 goes to 0. Then we insert another element which is 4. The TOS is incremented by 1. Now for example, we push 5 in there, the TOS incremented to 2. For example, we push 1, it is incremented to 3. Whenever we push like something like 10, it is incremented to 4, 7, and so on, 8, 11. Now this is a condition, and this the stack is full. Now let's see, when does this condition exactly occur. The condition where the stack is full occur when TOS, top of the stack, is pointing to the max -1. Here max refers to number of elements, number of maximum elements in the stack, and so in this stack the number of maximum elements is 1, 2, 3, 4, 5, 6, 7, 8. So max equal to 8. TOS is max -1. Is that max -1 means 8 minus 1 equal to 7. Now TOS is at 7, and our max -1 is also 7. So basically whenever TOS equal to max -1, the stack is full, and whenever we try to insert any other element into the stack at this time, it will give a message of stack overflow. And whenever we try to delete or we try to pop an element from the stack, whenever TOS is set to -1, which basically means the stack is empty, the program will print or give an output as stack underflow, which basically means the stack is empty and we are trying to push elements into it. Now let's understand the code for it, for two main operations, push and pop. Now here two basic elements are two basic variables are required before we move forward. Those are max, as I said, forward the most number of maximum elements in the stack. So let us take it as 5 here, and max plus TOS. TOS is initially pointed to at -1 as I first discussed. So push. Now so first let's make a function which is full. Full is basically a function which will help us. Full is basically a function which will tell us if the stack is full or not. If the stack is full, we will just we will have to return the condition of stack overflow. If it is not, we can move forward. So full will go we will check TOS. If TOS equal to max -1, the condition is true. Full condition will be true. Okay, and else if if TOS is not equal to -1, the condition will be false. So basically, if TOS is at any position other than max -1, the stack is not full, and we can move forward with the procedure. So this is the full function, and now let's go move forward with this. Now let's make the main function of push. So push, and in bracket our data that we have to push in the stack, we take that. Now moving forward, let's first check if the stack is full or not. If stack is not full, okay, if stack is not full, then proceed forward with first you have to increment the top top of the stack by 1. Top of the stack equal to top of stack plus 1, or we can even use TOS plus plus. Or okay, now first we increment the TOS to its next position, and then we push, or we insert the element into the stack. So then it will be, let us assume the name of the stack is ARR again. So let's insert the element ARR of TOS equal to data. Now basically this data will be pushed into the top of the stack, which is incremented before. So now this completes our okay. Or we also have to give our else whenever, if the this is the condition when the stack is not full, but if the stack is full it will go to else, and we have to print f here stack overflow. Okay, stack overflow. Now this completes our basic function of push in stack. So I hope you guys understood that. Now let's move on to our last part, which is pop. How does pop work in stack? Now for pop, first we have to, as we first examined the is full function in while pushing the element in pop, we have to first check for is empty, if the stack is empty or not. If the stack is empty, we have to return is underflow condition. So when will the stack be empty? When TOS is equal to -1. So if, as discussed before, if TOS equal to -1, return true. Okay, return true or true. This is a rough code. So yeah, return true, else return false. So this is our basic is empty function. Now as before, again pop function, no, here we won't pass on data, as we will push as we will pop the data on the top of the stack. So we don't have an option to push any particular pop any particular data out of the stack, or data value out of the stack. We have to always pop out the top of the stack value, the value at the top of the stack. So pop, let's first check is empty. If okay, if is empty, if it is not empty, then we can move forward. We can move forward as data. Okay, let's take a variable data where we store our deleted element from the stack. So data equal to ARR of TOS, and then after we give the element of the stack to the data, after we delete it, then we decrement the TOS pointer by 1. TOS equal to TOS -1 or TOS minus. Now this is the basic functionality. This is the basic operation we perform, and we have to also give the else here as we have done before. Else printf, if the stack is empty, then we give printf underflow condition. Okay, now this concludes our push and pop operation. This is a very easy code to understand, and I hope you guys understood it. Thank you for watching. Goodbye.